And then what are the challenges we're facing, with accelerating data lake queries today? So what is causing the users to kind of ingest their data into to somewhere else, not on their data lake, to accelerate their queries, right? So this is the challenge of ETL pipelines. So consider this example right here. So imagine if you have some data on your data lake and you build some sort of front-end application. You have your data users, right? And they identify some kind of slow query. And so you have to somehow optimize that slow query, right? And you add a pre-computation to your data pipeline. And that can be a denormalization pipeline where you flatten some of your normalized tables into a bigger flat table so you can save the join cost, at query execution to make it faster. Or you can maybe do a pre-aggregation, right, on the dimensions that's really expensive to high cardinality, maybe a high cardinality dimension that's expensive on the query side, right? And you write that result into another table, and then your data user, in order to take advantage of that performance gain, they have to rewrite the SQLs to point their SQL to the new tables that you just created, right? It's probably okay for a SQL that's 50 lines, but in the field we see like 5,000 line SQLs, and that's really not a simple Control F can do. And this creates a lot of problem, right? And this actually forces the engineers, the platform engineers, to figure out all of the data pipelines, all of the pre-computation that they want to do prior to developing the client-side application, aka writing the SQL scripts, right? And this creates a lot of problem, right? Like planning ahead, because like doing it afterward, it's so expensive. So when you plan ahead, you plan a little more than you need, right? So it's really possible that you're building pipelines to generate tables, pre-computed tables that might never get used or rarely get used, right? And this cost, the planning is not a simple task, right? It involves a lot of testing, a lot of reasoning. Just it's gonna really make your development cycle a lot longer. So you go to production uh, uh, in a longer time, right? Slower. The reason for that being, the reason we see the ETL pipelines are not really adapt to what we're doing today is because query engines are actually getting faster. So ETL pipelines are now being built on demand instead of default, right? Like imagine like probably 10 years back, when query engines are still slow, you would have to basically pre-compute everything, right? Not even joins, but aggregations too, right? You have to basically pre-compute everything. So there is really no planning to do. So you have your normalized data on the data lake, and you can start a like a bunch of map reduced jobs, or with your Spark cluster, you would have to create every single flat tables or pre-aggregated tables, right? And sync them there. So it wasn't really a problem, when we're doing pre-computation by default. But now query engines are running so much faster that we can do a lot more on the fly computation, right? So this planning part becomes a really big problem, right? So what is the solution? The solution is Starbucks materialized view, and we're gonna get into that in this section, right?